Once again, my name is Don Bowman. I'm the Vice President of Engineering and Operations for Wake Electric. We are a rural utility just north of Raleigh, North Carolina. And we serve a very low density compared to most utilities. We have 47,000 members, but we're spread over 7 counties. And a lot of the decisions that we have to make really fall on that side of the equation of saving money and really gaining the operational efficiencies in order to achieve customer satisfaction. We are surrounded by the Duke Energies and the municipalities of the world that have have high densities and different operational metrics. We have to compete and be competitive in that. And so we are choosing a lot of our technology strategies based on lowering our operational costs and being a more efficient utility.
Don, sorry to interrupt you a moment. Could you put the full screen on? We're only seeing we're seeing, I think, speaker mode.
Okay, 1 second. I will do that. Let me see if I can stop sharing for a second.
There we go. And now if you put full screen at the bottom, yeah.
I'm afraid that if I do that, let me, I'm afraid if I do that, it's going to go back to the other one. Let me do this. Let's see what happens. Does that work?
No, we're back in the same view again.
Okay.
Don, what you have to do is go to the top and hover over display. Oh, okay. When you present, you need to go to the top, and there's an option to switch viewing screen.
All right.
I think it's in the display settings.
Does that work?
Yeah.
Perfect.
Okay. Sorry about that, everyone. We have chosen really in our strategy with 7 steps to digitalization roadmap. Of course, we called this smart grid when we started in 2009, and in 2010 we changed to grid modernization. Now we're saying digitalization. Our 7 steps really started with a telecommunications evaluation, and I think Claire put this also as one of her first strategies there, was to do a complete evaluation of your terrain. Now, we know that across the world, there are different terrains and technologies deployed already that make everyone different. And what we found at Wake Electric was that we had to have a very hybrid approach, because we had very strong public networks in some regions, and then some regions of our territory, we needed to develop our own telecommunications strategy. So we have a hybrid of fixed radio. We have a little bit of fiber, not very much fiber optics available to us, but the public network ended up being a very strong player for us. So a lot of what we're doing is using the public network availability. And we also had to take a look at what tower infrastructure was around our territory. Once we were able to establish which telecommunication platforms we had available to us, it was really the first step was to decide on what we called our data gathering technologies. And our data gathering technologies are listed as advanced metering infrastructure, or AMI, also smart meters in certain circles, SCADA systems, which I understand a lot of you probably have a SCADA system already, that we consider that a very vital data gatherer. The other one is geographic information systems. And don't think of geographic information system as strictly mapping, because it is also your model at which your connectivity is based. And by connectivity, meaning how do you connect that end user all the way back to the generation source, is very, very important as you start to put programs and applications together on this. And then, of course, a customer information system, that is which stores the data usage, to source any interaction you have with an end user to understand power quality, usage, load factor, and of course demand. We need a place to put all of that data and store it by account. So go to the next slide. After that, one of the parts that we realized we needed right away is that once you start to put these data gatherers into place, you are immediately inundated with data. It's so much data that you really have to pay close attention to whether the data is accurate, whether it's been corrupted, whether it's any data is missing. And we found that having a strong data management, including a VEE technology, and VEE stands for validation, editing, and estimation. Because one of the first reasons we wanted VEE was for AMI. We knew an end result was we wanted to share smart meter data all the way to the end user. And we wanted our end user to trust that data. And we know that when you're getting millions of reads a day from smart meters, the chances of missing data is strong. And so what if you're presenting that data directly to the end user and the data does not match up with their usage? That we found that was going to put a trust factor in with our members, that we needed to make sure that that data was validated and edited and estimated before we sent it out for showing. So that's one example. But of course, any data that you're going to eventually merge into other applications, need to make sure that that data is validated before it's added to other applications. Speaking of added into other applications, the real next step is getting it from that data management to a data enterprise system. And that is just your gathering point of all this data, taking all the data from the individual systems and putting it into one database. Now, we understand that that requires a major IT endeavor. And a lot of times when we think about this, we had to, at Wake Electric, consider whether we had the capability as a medium-sized utility to manage that data ourselves, or did we have to get that hosted. And we ended up going with a hosted solution. So all of our data, once it gets aggregated, it goes to a cloud application so that we can now use that data in multiple applications from there. So that was a decision that we had to make. And I put this slide in there just to say that this has taken utilities a while to get to understand the benefits of cloud computing. We've always been very protective of our data, and now we are in the situation where we are going to have to trust cloud computing, because a lot of us don't have the resources and IT resources to support the amount of data we'll be managing. And on this slide, I put utility cloud, because all of the cloud computing we use are actually provided by utility vendors that specialize in this. This is not just a web enabled data service. This is a utility cloud hosted service that we use. And so we made sure we kept it in a utility format with experts that knew what they were doing with the data for us. And of course, bringing that into play, we recognize that this is where Wake Electric decided cybersecurity was absolutely mandatory. And so we basically put a bubble around this and make this our fifth part of our roadmap. And we do this with very advanced firewall management, password management, vendor provided tools. I say vendor provided tools because we now write into all of our specs the requirements of cybersecurity to be provided by the vendors we buy from. We make sure that they meet the expectations of some of the federal and local regulations for cybersecurity. We are also paying very close attention to what how this technology is moving for utilities. We have found that a lot of these arrows that go in between these steps that you see here are very known data. And what I mean by known data is the data is very recognizable and expected to flow between this point and this point. And so we're following a lot of technologies that are simply learning technologies that learn what data is supposed to go from this point to this point. And instead of putting more virus protection and malware detection, we're actually detecting abnormal data, because that's really what we want to see. We want to see data that doesn't belong in there and just kick that out. That's more of a learning technology, but we're really paying close attention to this. But this is the part of the roadmap that we feel have to be enveloped into a cybersecurity management platform. And I believe that this is the step, which is, we call this the critical tool creation step for our utility. All that we have done so far up until this point we are doing for individual purposes. We put in AMI just so we can read the meters. We put in SCADA just so that we can do some remote control. We put in GIS just so we had digital maps, and we put CIS in just so we had a customer management system. But now that we have all that data secured in a data enterprise system, we can start filtering that into multiple applications, such as outage management. Outage management is not simply coming from a single data gatherer. Outage management comes from the data from smart meters. It comes from the data of our reclosers and our substation devices. It comes from our mapping, because it has to know the connectivity model. And it comes from our customer information system, because it actually identifies the members affected by an outage. So all of those pieces have to be merged into a system to create outage management system. Distribution automation, that comes from connectivity and the SCADA system. So it's the combination of SCADA and GIS. Demand response starts to get into more of that energy management system that we're putting together. Is how do we reduce demand during our peak times? Obviously, system efficiency studies, distributed energy management, and member engagement. Now suddenly that we have all this data that is normally secured in a very secure place, if we get it in the right place, we have the ability to share that data with our members to increase their satisfaction and give them the tools to make some local energy management decisions. I put this as an example of how we merge systems together. A lot of times AMI vendors or smart meter vendors would actually indicate that they have tamper detection alerts. Well, we found that tamper detection alerts came when someone pulled a meter. Well, a lot of times, 99% of the times, our own service people are pulling meters. And since the AMI and smart meter system had no way of determining whether it was our folks that were pulling meters or a power thief was pulling the meter to tamper with the meter, we had to merge the data from our CIS and workforce management system and merge that with our AMI data to say, okay, we got a tamper alert. Was there an active service order already on that meter? If so, we make the assumption that our own service people were the ones pulling that meter, versus if we don't have a service order already attached to that consumer, then we assume it's a tamper and we need to investigate for power theft. But we had to have those systems integrated in order to create a dashboard like this. I'm going to just briefly talk about conservation voltage reduction, in that we use multiple third-party vendors to help us achieve this. But let me explain a little bit about what voltage reduction is. We get a lot of our wholesale power costs are wrapped up in our peak demand, our coincidental peak demand from our wholesale provider. And we saw an opportunity to lower our peak demand by lowering voltage across our system at strategic times. And this is an example. We have a SCADA system that is constantly monitoring our load. We have all of our AMI devices that are monitoring real-time voltages. We have our SCADA system is also monitoring our voltage regulators. So at a given program time, we have an application that across our system lowers the voltage regulators until our voltage at the end of the line sends alarms to say we've gone far enough to stay within the local regulatory standards of ANSI standards to meet that. In this example you see on the screen, the green line is an actual reading. The darker shaded area is when we were peaking during our coincidental peak with our provider. And as you can see, the blue line represents a typical day. So what we've done here is activated voltage reduction, lowered our demand by, you see that dip that the green line took. We are able to measure the typical line of that red line is what we would have forecasted would have happened had we not gone into voltage reduction. The savings here add up to about 4 to 5 megawatts of savings. That's equivalent to about $75,000 to $95,000 worth of savings at that one moment with this system. On average, we spend about $50,000 per year to maintain this system. So you can see that this type of ROI really exists in a very meaningful way, and it's been very good for our utility. So our final step of our digitalization roadmap is, now that we've created these individual applications, we know now, and this comes down to what Claire said about training and how important it was for the safety of our folks and the effectiveness of these applications. We have to create customizable dashboards that allow management teams to look at these individual applications in a way that help them make decisions of when to enable them, when to use them, how to set them up. And also, we also want to give customizable dashboards all the way down to our folks in the field. Our line people that are out in the field need to know what distribution automation activities. So we are now displaying SCADA images all the way down to the truck level, so that they can see readouts, they can see feeder levels, they can see where the feed is coming from at any given time. We thought that was very important for the safety and the buy-in from those folks on the digitalization. And then, of course, the system and process automation. What we want to ultimately get to is an area where we are not manually managing any of these interfaces, but they are programmed to be implemented at given times that make sense for our utility. For example, distribution automation recognizes a fault, automatically reroutes power from the appropriate source to minimize the impact. We want that to be automated. We want our demand response to be automated based on our current load factor and what signals we're getting from our wholesale provider. And of course, system efficiency studies aren't just historic. We want them to be real time, and we want to know real time exactly what's going on our system and what changes we can make that would greatly affect wholesale costs or operating efficiencies for that. So in summary, Wake Electric is very proud of the steps we've taken in the last 10 years. And the 7 steps, again, we're evaluating our telecommunications available within our territory, establishing some foundation technologies. We call those data gatherers, data management, making sure that data stays valid and is good data to work with. We needed a system to bring that data into one enterprise location. We then needed to envelop all of that technology into a cybersecurity plan. From there, once we had everything, we knew the data was good and secure, we created valuable tools that met new needs that went far beyond the initial data gatherer applications that we were using. And now the step that we're currently in is building interfaces and building automation that make that easier to use and more buy-in from the rest of our employees as we move forward. So I welcome any questions that you have about the steps that Wake Electric took, and can make my phone number and email available to you along with these slides after the presentation.